Buffer systems of dihydrogen phosphate and hydrogen phosphate are often used to support cancer cell cultures in research labs. This really is something that comes up, since ordering custom buffer solutions is a lot more expensive than preparing them yourself from the salt precursors. If the cells in this particular culture require a pH of 6.75 and a combined concentration of no more than 0.200 molar, how much of each of the sodium salts is needed to prepare 20 liters of buffer? To begin with, we'll need a few more pieces of data. The pKa of dihydrogen phosphate is 7.19. The molar weight of the sodium dihydrogen phosphate salt is 120 grams per mole, and the molar mass of the sodium hydrogen phosphate salt is 142 grams per mole. So let's start with getting the pH right. Henderson-Hasselbalch tells us that the pH is determined by the ratio of the two ions, so we can calculate that ratio even without knowing exactly how much of each we're going to need. We can arrange the equations so that the logarithm of the base divided by the acid is equal to pH minus pKa. That means that the logarithm of the base over the acid is negative 0.44. So the ratio of base to acid is 10 to the negative 0.44, or 0.36. That means that the concentration of the base is 36% of the concentration of the acid, which makes sense based on what we already know. Since the pKa is 7.19, there has to be more acid than base to bring it down to 6.75. So whatever particular amounts we use, as long as the amount of base is 0.36 times the amount of acid, then we're good. So let's address the second requirement, that the concentration of the hydrogen phosphate and the concentration of the dihydrogen phosphate is no more than 0.200 molar, or we'll say that it's equal to 0.200 molar. That's to say that the acid is 0.200 minus the base. So if we substitute that into our first equation, then the concentration of the base is equal to 0.36 times 0.200 minus the concentration of the base. And with a little arithmetic, we find that the concentration of the base is 0.053 molar, which means that the concentration of the acid is 0.200 minus 0.053, or 0.147 molar. And to achieve these concentrations in 20 liters, we'll need 20 liters times the concentration of the hydrogen phosphate times the molar mass of the hydrogen phosphate, means that we need 150 grams of sodium hydrogen phosphate. And doing the same process for the sodium dihydrogen phosphate means that we'll need 353 grams of that. So 353 grams of the acid, 150 grams of the base, mix those together in 20 liters of water, and we have our final answer.